This podcast is brought to you by Enlightening Learners Academic Coaching and Tutoring Services. In this presentation, we're going to go ahead and talk about solving proportions. Guided questions you'll be responsible for. Define the terms ratio and proportions. Determine how a ratio is related to proportion. Determine how you set up a proportion, and finally, how do you determine if a ratio is a proportion. So a ratio is the comparison of two numbers written as a fraction. So as an example, if I'm talking about a ratio, let's say, of 1 to 2, meaning for every one orange that I have, I've got 2 apples. Or if 1 boy to 2 girls. Those are ratios. When we have 2 ratios that are separated between an equal sign, it's called a proportion. So 1 boy to 2 girls is the same thing as 2 boys to 4 girls. Now, a proportion can be written as 2 fractions, or it can be written as a colon, with the colon separating the 2 things being compared and 2 colons comparing the 2 different ratios. So if I'm writing it as a colon notation, this is one ratio, this is another ratio, and when they're separated by 2 colons, 2 sets of colons, that's the equal sign. Now, for the majority of cases, you're going to be showing it like this, where you've got 2 fractions that are separated between an equal sign. Now, when we set up proportions, think part to whole, meaning you've got part of something over whole of something, and you're doing that on both sides. Where students make mistakes is if one side is a part over whole and this side is a whole over part. And you'll typically see them in story type problems. So as an example, if you can travel 120 miles on 6 gallons of gas, how far can you drive on 8 gallons of gas? Well, we're setting this as gas over miles is equal to gas over miles. This first part is 6 gallons over 120 miles, so I'm going to set that like this. Now, how far can you drive on 8 gallons of gas? I need to know the miles, and I've been given the gas. So in this situation, what I do is cross multiply. I can always reduce if I want to, but it's just as easy to do it this way. So 6x equals 960. And then finally, to solve for x, I'm going to divide both sides by 6. 960 divided by 6. 6 can go into 9 one time. Six can go into 36 6 times. And I bring down another 0. So my answer is 160. Now, the final question of the proportions ratio are the following proportions equal to each other. We know that they're equal to each other if, when this all gets cross-reduced, that one side equals another. So we look to see if we can reduce. I know that this can go into that 3 times. And at the end of the day, well, let me make this even easier. To see if these are equal, just simply cross multiply. 7 times 4 is 28. 9 times 3 is 27. 28 does not equal 27. So this is a false statement. They don't equal each other, they're not proportions. Likewise again, 4 times 20 is 80, equals 9 times 9 is 81. 80 does not equal 81, so it's not proportionate. These are not proportions. Now you notice that when I'm doing this, I'm going from bottom to top and from bottom to top. 9 times 12 is 108. 27 times 4 is also 108. So these are proportions. Finally, 18 times 4 is 72, and 9 times 8 is 72. So these equal each other. They are proportions, and this is a proportion. These two are not. Finally, you're going to be given a series of proportions where you cross multiply and solve. 3 times 21 is 63, equals my unknown, which is my x, and I simply divide both sides by 9. X equals 4. These cancel each other out. 36 divided by 9 can be simplified to 4 over 1. This one is 10x equals 4 times 5 is 20. Divide both sides by 10. X equals 2. And finally, we've got 3 proportions. Okay. The easy way to do this is to see what this equals. So 12. So we're going to make 4 times 3, 12. 12 over 1 is 12. So these are in fact proportions. But what we need to do is to figure out what this one is going to be. Now, if you look at the pattern here, there's always going to be a pattern when you're dealing with proportions. 1 times what is 3? That's a 3. This is being increased 3 times. So the other question is 3 times what? Gets me to 9. And frankly, it's another 3. So to find this one, I need to figure out the pace, the pattern that's involved in the denominators. Well, I'm multiplying this by 3, so if I multiply this one by 3, I'm going to get that answer. 12 times 3 is 36, so this unknown is going to be 36. Now, hopefully that makes it a little more clear. So just look for the pattern, and in each of these cases you notice that there's a pattern that's evolving.